to Engineer's Workshop. I'm over here at the K&T because in my last video repairing that injection pump, I promised you a new project I was going to be starting at, a low stress project, something that's been sitting on the on the table here for a long time, and that's the upper arm casting for the Rockwell 16 inch radial arm saw. I broke this in disassembling it, trying to get the lock knob off, which had a left-hand thread, unbeknownst to me. And I ended up making a new extension on this using the original stud, brazing on a chunk of an old wrist pin here. But I've got heavy weld bumps on the inside of that bore that protrudes in here, and I need to clean that up. And I can't really open this up because this actually has a cut in it, and it clamps down on the pivot. Like there's a quill that goes in here, holds the actual traveling arm, and to lock it at your different positions, this cast iron casting actually crushes down against it. So I don't want to open it up at all. And I've been struggling to figure out how I'm going to mill this down. I'm going to do it with a combination of some cutters, some milling cutters that I have that are slightly bigger than the shank to get the biggest parts down. And then I'm going to use this boring head. This is a Bridgeport #2, and I love this thing. I used it on the body of the Bosch injection pump, and it's a very nice running, nice adjusting head. So I'm going to use this, but I'm going to make an extension on this that Dee Dee showed. He called it a Jig-Bore style boring head. And it's basically a chunk that goes on top of this with the cutter mounted in it, and it adds a lot of mass to this. And so I bought a piece of, I believe it's 4140 preheat treat, that I'm going to machine and go on top of this adjusting block here, and it's going to be essentially for the diameter range of this. This is like 4 1/4, but it still will offset this way and that with the standard dial here. But it'll be a nice beefy head, and I'm going to hold these massive inserts that I have. Let's see if I can get you to focus on this here. These are some hefty carbide inserts. Opening this up, so I'm going to get the Kurt vise off of here, give the table a good clean up, and get this fixtured back in here for machining. So here's the Bridgeport #2 boring head, and I've got this chunk of 4-inch round. I'm basically going to make a pocket in it, and then this is going to recess into that extension, and then this entire piece will offset left and right to do bores anywhere from about 4 1/4 up. The radial arm saw is 4 1/2 inches, so it's perfect size for this. So, and I got these big inserts. Just there's no relief to these, so these have to be run in like a negative holder. Let me show you the CAD model of what I'm going to do here, and then we'll start working on this, taking it down to size. Like a lot of my projects, I start out with a SolidWorks model to better visualize things and get the features in the right place. I'm basing this around a 4-inch round, and this is 2 1/2 inches tall. There's nothing magic about that dimension. It's just what would conveniently put the features on the opposite ends, not interfering with each other. It could go significantly shorter. There's no particular advantage for it being any taller than that, but I'll see what I'm working with and pare it down until it's probably no taller than 2 1/2 inches. So anyway, on the top side, I have a rectangular pocket, and that pocket is going to start out with 4 3/8 drilled holes that are deep enough to allow, I went for a 3/8 diameter milling cutter to mill this out. I can rough it with something bigger, but finishing these faces here, I could get directly into those corners with a 3/8 diameter cutter. And right now that's 1 inch deep. There's a couple of socket head cap screws in from the back side, which are going to go into cross dowels. I'll explain that in a minute. And then there's a pocket here with a threaded hole on the side where the insert is going to be held. And the only other exterior feature is a threaded hole here, which is going to use a set screw to preload the boring head against that face. So let's take a look at what this is going to look like in the assembly. Here I have the Bridgeport number 2 boring head modeled, and I mentioned about the socket head cap screws going into features. Basically, in this bore, since there's really nothing to fasten to, I remembered these items called cross dowels, and they're available from McMaster. It's really a woodworking item, but it's a round section of steel bar with a threaded cross hole in it, and they're available in a number of different sizes. So I found a mating diameter for this and bought a couple of them, and they'll slip in here, and then the 3/8 socket head cap screws will clamp this boring head with that face against the underside face of the boring head, and it'll make a nice rigid setup. This is what everything will look like basically in place. So you can see that the boring head is nested up against the adjusting block. I've got a little bit of a gap here so that it is definitely mating against that surface. Now the insert, I showed you the big inserts that I have, and I'm going to use a slot that is, this plane right here is on the center line axis of the boring head. If you were to draw a center line, that would be right along that plane there. But the cutting edge is this corner here. So if I were to take a circle and I come out and I make this tangent at that point, you can see that I've got slightly negative rake, and I've got a little bit of a clearance angle here, and if you measure that, that's basically about 5 degrees. So I've got a 5-degree clearance angle, about a 5-degree negative rake. It's actually a 7-degree clearance, and so we've got a 7-degree negative approach angle and a 7-degree clearance. And that is basically using that point as the cutting edge. Now let me show you the way I'm holding this in place. So I have a 3/8 diameter ball bearing that is going to drop into the mounting hole of the insert and is going to be held pressure against the insert, keeping it in contact with that back face by a cup point set screw. And I'll probably have to improve the cup angle on that. But this is going to eccentrically load this insert so that it is basically held against that face and that face. So it's not going to bear evenly on this cone. The cone is actually going to force the insert and jam it into the corner created by those two surfaces. And hopefully that will keep everything tight enough to give us a clean cut. So let's go over to the shop and let's start roughing out the diameter of this piece, and then it's going to be over to the K&T to put in the pocket on the back side and this slot for the insert. Only going to run this with the jaws sticking out this far enough to face it, and then I'm going to flip it over and reverse the jaws to clean up the OD. It's deep enough to be gripped by the jaws when I reverse it. Thought my steel blank was 4140, it's just 1018. And it was sold as a 4-inch diameter by 2.5-inch length. It's actually 4040. And it cleaned up at, over 4 inches, 4022. And it is right at 2.5 inches, so got a few thousandths I can take off without going much under that dimension. And hope I can dress the OD down. Let me double check what that is. If I can get my lathe tool in there. 4021.5. So we'll start by facing this off, cleaning up just as much as we need to, and then we'll dress the OD down to that point, and then we can start putting features on it. I might go ahead and chamfer the corners while I got it in the lathe. If I cock my tool holder just a bit, I can reach past that chuck jaw there and clean up all the way to the other surface. I should have run that a little deeper. Okay, I'm going to try to hit this in one shot. The OD doesn't have any significance, but let's see what we can do here. I'm going to put a little finer feed on this. I got a pretty coarse feed from my last operation. This is about a 4/1000 feed. And that's within about 1/1000 of this original diameter up here. So let's put a chamfer on it. $21.5 over on my diameter, so I'll just modify my SolidWorks model a tiny bit to reflect that, and I'm only 0.4 under 2.5 inches here. I'm at 2,496, so that's a good starting point for going over to the K and T and getting this set up, probably with some aluminum backing in the Kurt vise to locate and begin that top pocket. Well, I did the rough out on the boring head, and at this point it looks like this. So I'm holding this featureless round piece, and I'm saying to myself, how am I going to locate all of these features and be able to, flip the part top to bottom and get, this slot aligned with this slot, find my setters, etc. And I said, well, easiest thing would be put a couple of flats on it. And good, but unless the flats are exactly centered about the axis of the part, I no longer know where the side-to-side location for that upper recess is, so I figured it'd be best to leave about an 1/8 inch tall boss. That way I can hold the part in the vise, but I have this pre-made feature on the round part to indicate off of. And then same for the bottom. If I put a recess in the bottom, I have essentially a complete surface. Don't have quite a complete surface because of this cutout, but I have something to indicate off of and locate the center of the part. And then the only thing I need to do is rechamfer those outer edges. So I'm going to go ahead and add those on the lathe before I take this thing over to the K&T and put these flats on. I'll probably have to drill a center hole. Maybe I can do it with a flat end mill, 1/8 inch deep, and carbide boring bars, and open up this side to, it's about a 2.5 inch diameter. This side's pretty easy, 3.5 inch, just turn a recess and rechamfer those corners. So let's go ahead and do those before we call it done on the lathe. I've got a reference drawing started with the couple of features I need to put on here, dimensioned 3 3/16 top boss, 1/8 inch tall, and a 2.5 inch recess on the bottom, 1/8 inch deep. So let's go ahead and knock these out on the lathe. I'm going to try to get my diameter to correspond with the reading on the dial here. 3/610. I think that's close enough for a start. So we'll go ahead and back it off and pare it down to almost that point until we're at the stop here. Got some heat into those chips. .198. This diameter doesn't have to particularly be exact, but it's nice to hit your target. How about that? Well, that wasn't working out so well. So let's change over the setup to something that hopefully will work better. I'm just looking to get a 1/8 inch deep recess here to start with my boring bar. Much better. And once again, the 1/8 inch isn't critical. Just need something deep enough to indicate. Switched over to a little bit more robust boring bar. We'll see if this screams a little less loudly. It'll definitely take a heftier cut. I'm a little big. No, I'm not big. 2.5. I'm at 2 inches, 440 thousandths, so 60 thousandths more to go. It should be within 10. Yep, I'm actually 4 thousandths big. I'm just going to take a little bit of a cleanup cut. It is a nasty, chattery finish. Went a little oversized, but that is much, much nicer looking. Well, with the lathe work done, that's a good stopping point. Got a means to indicate when I'm doing that pocket in here. Got an OD I can indicate on, and on the backside or the underside, I've got an ID that I can indicate on to locate. And next will be 2 flats, which, as you can see, will not encroach on that surface, but it'll give me an orientation so I can go from one side to the other and stay parallel. So part 2 will be the upper pocket on this. Thanks for watching. Thanks for subscribing. Stay tuned for more updates. And as always, until next time from Engineers Workshop, stay safe.